All right, guys, let's go ahead and get started on this. All right, so this one assignment is due tonight. If you need any help, refer to this video, rewind it, fast forward it if you don't need this problem. Either way, get the practice. Please don't just copy the answers. Okay, that does not help you in any way, shape, or form except become better at copying. Okay, so this is number 9. Swimming pool is 30 meters deep. 12 meters. Oh, sorry. Swimming pool is 30 meters long and 12 meters wide. All right, so let's draw the swimming pool. So we've got a swimming pool that's 30 meters long. So it's long this way. That's 30 meters, and then 12 meters wide, like that. So kind of like that. Okay, I'm trying to draw 3-dimensionally, so gonna see what's going on. The bottom of the pool is slanted, so the water depth is 1.3 meters at the shallow end. So at the, let's say this is a shallow end, so this is 1.3 meter. And 4 meters at the deep end. So let's say right there. So your swimming pool kind of looks like this. And then this is the same back there. So that's a slant. So this is the shallow end right here. And this is the deep end. Okay. So it says find the angle of depression at the bottom of the pool. Right. So so how is this slanted, right? So at the bottom of the pool, what's the angle of depression? So basically, if I was to look straight up right here, straight across, that will also be 1.3 across. Right? And we want to know this angle over here, this angle that's sliding downward. So this is called the angle of depression. We'll call that theta. Okay, so we just want to find out that angle, right? So if we look at this, that's 1.3 on this side and 1.3 on this side, then this leaves you with 4 minus 1.3, right? So 4 take away 1.3 gives you 2.7. So that means that this right here is 2.7. That's a 90 degree right here. And that right there is the same as 30. So we want to find the angle of depression. So that would be, let's see, if we're at that theta here, this would be the opposite and the adjacent. All right, so with SOHCAHTOA, opposite and adjacent is going to be the TOA. So we would need to do a tangent. Oops. Okay, so we got tangent of theta equals the opposite, which is 2.7, over the adjacent, is 30. And to do this, we need to do we need to inverse tangent both sides. All right, so we will end up with theta equals tangent inverse of 2.7 over 30. Now you think about it, this should be a pretty small slope, right? Or pretty small angle of depression. So I'm going to go ahead. Make sure you're in degree mode, which I am. So we got tangent inverse 2.7 divided by 30. And we got 5.14 degrees. So theta equals 5.14. And if you want more numbers, you can put more numbers. But I'm going to go ahead and stick with 5.1 because The worst number on it in here is the 1.3. So at one decimal place. So I'm going to go ahead with 5.1 meter. Okay. Excuse me, 5.1 degrees. All right. Actually, I'm going to try to go a little faster. Sorry about that, guys. So we got theta. The angle of depression is 5.1 degrees. Okay, if you need it, pause it before I delete all of it. Number 10. Okay, the tallest, a rhombus diagonals ABC with ABCD with diagonals AC and BD meet at point E. If the measure of the angle DA, okay, it's 46. What's the length of EB? Okay, so rhombus is actually kind of like a kite, but it's actually perfect. Okay, rhombus is kind of like is actually a diamond. So that means that all four sides are exactly the same. So we'll label it A, B. You can label it any way you want. C, D. It's gonna end up being the same. AC, this diagonal, and BD meets at point E. The measure of the angle DAB. So let's see. DAB is 46. So this whole thing is 46, which means because it's a rhombus and it's a parallelogram, that each of these angles are 23. Okay. Find the length of EB. So just that little piece. All right. So I'm going to go ahead and draw this triangle out. Right. So that looks like, oh, phone call. Excuse me.
I emailed her already. I emailed her, and tonight there's no homework except they got to do some work out of their book. She has an ebook or from their Chromebook. Okay. Mm-hmm. Bye.
Sorry about that. All right, and then we got 23 degrees here. So let's see. Hmm. Meter point diagonals. Meter point E is the measure of angle. Find the length of EB. This is A, B, E. I'm actually not sure about this one. We don't have anything else unless I deleted that. Numbers A, B, C, D, diagonal AC and BD. Meter point E. That means they're the same length. That means, let's see. If the measure of angle DB is 46, find the length of EB. You know what, guys? I'm not sure about this one. I think we don't have enough information. And let's see. Rhombus, that means that this side is the same as that side, and this top part is the same as that bottom part. But we don't know anything about. I mean, we could find out the other angle over here. Go 180 minus 90 minus 23. That gets you 67. So we know this is 67 here. Okay, but that doesn't tell you about anything about the sides. Yeah, you know what? Let's see. This one, let me think about it. All right, guys. Sorry about that. Let me think about this one. Let's look at number 11. Trying to not take my sweet time and everything. Okay, we'll come back to 10. Okay, well, I'll put some question marks. If anything, I'll maybe talk about it tomorrow. Tallest television transmitting tower in the world is in North Dakota, and it is that feet tall, 20,059 feet tall. If you're on level ground exactly from the base, so let's just gonna draw it out. So tallest television tower. So we're just gonna. Okay, that's antenna. Okay, and it's two 2,059 feet tall. If you're on level ground, exactly 5,280 feet from the base of the tower. What's your angle of elevation? Look it up at the top of the tower. So this one's pretty straightforward. You're right here, right? And disregarding how tall you are, we want to find out what's your angle of elevation if you're looking at the top. So we want to find theta right here. Yeah. So that one is opposite and adjacent with a 90-degree angle right here. So we're looking at tangent. So we got tangent. Theta equals opposite 2059 over the adjacent, which is 5280. Inverse tangent, both of those. So we got theta is equal to tangent inverse of 2059 over 5280. So we got inverse tangent 2059 divided by 5280. That gets you about 21.3 degrees. And looking at all of this, looks like whole numbers. So I'll say instead of 21.3, I'll say theta is approximately 20 degrees, 21 degrees. Okay, so your angle of elevation is about 21 degrees. So we'll say theta is approximately 21 degrees. Okay, number 12. We'll come back and look at that. We need to. Number 12. Ophelia Payne's walking to her office building, which she is known is 150 feet high. The angle to the top of the building from the current location is 6 degrees. How much further does she need to walk? Oh, this is a good problem. This is actually something that's not typical. Okay. So this chick, she's walking to her office building, right? In her office building, let's just draw like this. And she knows that it's 150 feet high. So 150 feet. Oops. doesn't matter about that. And then she knows that the angle to the top of the building from her current location. So the angle to the top is 6 degrees. We want to know how long is her walk to get to her office building. Again, this is a 90-degree for the office building right there. So looking at opposite and adjacent. So we're going to have to go and look at tangent again. Tangent of 6 degrees. This time we know the angle though is equal to the opposite, 150 feet, over the unknown, which is x. Right. This one, I'm going to go ahead and solve this by dividing it by 150 or multiplying it by 1 over 150. These are going to cancel, and you will have tangent 6 degrees over 150 equals 1 over x. I'm going to go ahead and flip both of those, so I'm going to get x equals 150 over tangent 6 degrees. Remember, when I flip it, it's actually x over 1. Okay, but because it's like this, I don't need to put the 1 underneath it anymore. So I am just going to go ahead and put x. All right, so in my calculator, I just got to figure out what x is by doing 150 divided by tangent of 6. Okay. She has 1,427 feet. So we'll say x is approximately. So she has approximately 1,427. Okay. So how much further does she need to walk? Approximately 1,427 feet more to walk. All right. That's number 12. Okay. 13. Observer Observer on the ground at point A watches a rocket ascend. The observer is 1,200 feet from the launch point B. Okay, so let's see. Just drawing it as it comes along. So observer is at point A. Okay, so this little guy right here, and he's looking out. And then point B, it's a rocket ship. Okay, that was ugly. And the observer is 1,200 feet from launch point B. As the rocket rises, the distance d from the observer to the rocket increases. And so as the rocket goes up, so if the rocket's all the way, so right now the distance from the observer to the rocket, right? The distance from the observer to the rocket is 1,200 feet because the shortest distance is a straight line. Okay, so we'll say to the bottom, to the butt of the rocket. But as the rocket goes up, now the distance is from here to the right here, which makes a 90-degree triangle. Okay, and as the rocket goes up some more, the distance is now even more. Okay, so that's the idea. Okay, so express a measure of angle A in terms of D. Oh, D is the distance right here. It says D is the distance from the observer to the rocket. Okay, so let's just say the rocket's like about right here. Right, so we have this triangle here. So from here to where it left off, here to the rocket, that's D right there. That's 90 degrees. All right, so we're looking at find the express a measure of angle A. So we are looking at this right here. So this is going to be so we don't have an opposite from where we're at, but we do have an adjacent and we have a hypotenuse. So cos, I think we're using the cosine, the adjacent and the hypotenuse. All right, so we're going to go cosine theta equals adjacent, which is 1,200 feet, over the hypotenuse, which we don't know. All right, to solve this, you're going to divide both sides by 1,200 feet, which is going to get rid of that. So we're going to get 1 over D, because 1,200 feet is gone, and we'll end up with cosine. And I'm not showing you the work again because I've done it twice already. So you're going to have to go back and look through what I did earlier. But we multiply both sides by 1,000. We multiply both sides by 1 over 1,200. And on the left hand side, it's like dividing it. So by doing this, and we are going to reciprocal both sides, we'll get 1,200 over cosine theta. Right? And that's what A is. So A is expressed a measure of angle A in terms of D. Oh, actually, we're done right here. So this is part A. um, so if we want to find angle, so we have to use this right here. If we want to find the angle theta, then that's going to be using the inverse cosine. So we will say theta equals cosine inverse of 1,200 over D. Okay, that's part A. Part B, find the measure of angle A if, sorry, so I don't need all of this. I was rewriting it in terms of the distance, but so we will have theta equals cosine inverse of 1,200, and it says if A is find the measure of angle A if D is 1,500. Yep. So what does that equal? All right. So let's pull up our calculator. So inverse cosine 1,200 divided by 1,500. Close that off. And this says that the angle is 36.8. So I'll say approximately 37. Okay, so theta is approximately 37 degrees. So we'll say theta is approximately 37 degrees. Find the angle, find the measure of angle A. If D is 2,000, so all we're doing is just changing it from 1,500 to 2,000. That's all I'm going to do on the calculator also. I'm going to pull it up again. And instead of 12,000 divided by 1,200 divided by 1,500, when divided by 2,000. Right? And 2,000 would mean that it would be, before we get the answer, think about this. 2,000 would mean that if this is 1,500 and the angle is 37, when it goes a little higher, and now this distance is 2,000, that means that this theta is now bigger. Right? So our answer for the next one should be bigger. Okay. So instead of 37 degrees, now it's going to be about 51 or 53 degrees. So 53.1 degrees. So I'll say theta is approximately 53 degrees. Okay. That's number 13. 14. At a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack is 35 degrees. And the angle of elevation to the top is 53. Find the height S of the smokestack. All right, so this, let me see. So we're looking at the ground again. At a point 200 feet from the base of a building. So here's a building. Okay. Here's a building. And here's a point. All right, so let's say that's 200 feet. And I guess a building angle of elevation to the bottom of a smokestack. So smokestack is, let's put this in red. It's kind of like a chimney, right? And that's where smoke comes out of. So from here, the angle of elevation to the bottom of the smokestack is, so from here to the bottom, so if you're looking up, is 35 degrees. And the angle of elevation, use purple, to the top is 53 degrees. So that right there is 53 degrees. Find the height of the smokestack, right? So we just want to find out how high is this right here on. What do you guys think? We've got, let's see. We can find the height of the building, and then we can find the height of the building and the smokestack. How about that? So let's do this. Let's find the height. So let's do this. Let's do this triangle here. This one first with a 35 degrees. Okay, that's a 90 degree there. So I'll use blue for this. So we have, let's see. And we're going to be looking at, we'll call it W. Okay. So we'll say this is the opposite and the adjacent. So we'll go, so that's tangent. So tangent of 35 degrees equals the opposite W over the adjacent, which is 200 feet. Right, so that means W would equal times both sides by 200, so it'd be 200 times tangent 35 degrees. So we got 200 times tangent 35 degrees. So the building itself is 140 feet tall. Okay. Now let's scratch this. Okay. Now let's look at a bigger. Let's look at this one. Triangle here. This will be utilizing the purple angle, the 53 degrees. And again, it would be the same thing again, but this time around, we got to find out y, which is from the building to the top of the smokestack, and then we'll have to do a subtraction, right? So we'll go tangent 53 degrees equals opposite, which is y, over the adjacent, which is 200. So y would equal 200 times tangent 53. Okay, so pretty much the same idea. So 200 times tangent, and you don't need to put a time, 53. Okay, don't put 35 again, it's 53 now. So that means that from the bottom of the building to the top of the smokestack is 265 0.4. Okay. And all we got to do is subtract these two numbers from each other. So I already have that. That's to the top. And I'm going to subtract the to the bottom of the to the just a building part. So 140.0415. I'm just going to copy all those numbers. 076. So that means that the smokestack itself is 125 feet tall. And these are all whole numbers. So I'll say the smokestack, okay, is approximately 125 feet tall. Okay, and that was the height of the building right here. Or sorry, take away the height of the building away from the height of the building and the smokestack. So 140 is the height of the building. That was what I did in the blue triangle, and then 265 is what I did in the purple triangle, which is the building and the smokestack. And subtract them, and you get 125.367. So I rounded, just round to about 125 feet. Okay. Okay, 15. A communications tower is built on top of a building with the following specifications. Great, another one, huh? So here's a building. And then here's a tower.
Good afternoon, students. Make sure to pick up your Cheez-Its, pineapple chunks, Italian coins, and milk at the second lunch window. For Cultural Club, Cultural Club is meeting in the cafeteria
I
at
could do
this
better.
time. The weight room is open for all students until 5:30. Glass Painting Club and Origami Club are canceled for today. In the library, we have Gaming Club, Chess Club, Lego Club, Virtual Reality
I think
Club.
this is the same thing.
The library is open for all students until
Around point
6:15.
20 meters from the
There
base.
are late buses today. There's a 4:45 and 6 o'clock late bus.
Angular elevation to the top of the building is
Have a great day.
23. This angle elevation 23.6 degrees. Angular elevation to the top of the tower is 15.9. Find the height of the communications tower. This is exactly the same thing, right? We have a 90 degree here. All right, so first we got to find out, and so I'm going to do the, let's do the whole thing first, right? So let's do this big one. So let's do, so use the blue. So this is the height of the building and the communications tower. And that one's going to utilize this 15.9 degrees. Okay, and let's call it X. Okay, so that's tangent 15.9 degrees equals X, which is the opposite over the adjacent, which is 200. So X would equal 200 times tangent 15.9 degrees. So find out what X is. I'm going to use my calculator for that. So clear it out. 200 times tangent 15.9 get you that. So that's the whole thing. So the whole thing is 56.9. So 56.97, right? So the whole thing, okay, I'm going to go and do away with that. Now we're going to look at just the height of the building, which is just this part. And we're going to utilize that 23.6. Oh, did I use the wrong numbers? Let's see. I think I got the numbers backwards because that angle, the blue angle, there's no way this blue angle could be 15.9. Let me read it again. Communication tower is built on top of a building with the following specs. Return from the base, the angle of elevation to the top of the tower, or to the top of the building is 23.6. The angle of elevation to the top of the tower and the height of the tower. I think they have it backwards here. I think we have the numbers backwards. That doesn't make sense. The angle elevation to the top of the tower. Yes, yeah, I think we have it backwards. So, this right here, this since we're using the 15.9, it's actually this right here. That's gonna be the that's how gonna be how high the building is. So I feel that these numbers are backwards. So that 15.9, I'm thinking it should be down there, and 23.6 should be up there. Because the to the top of the building should not be any bigger than to the top of, yeah. So I think this is what it is. Okay. So let's do it again, but this time we're gonna use a 23.6. So it's exactly the same setup. It's the opposite, which is gonna be unknown. It's gonna be this whole thing. The adjacent is gonna be 200, and then the angle is gonna be 23.6. Okay. So if we set up SOHCAHTOA again, it's gonna be the same idea, except this time 23.6. Okay, so you get 87 is going to be to the top. What is that? 87.3, 87.37. So to the top, it's going to be 87.37 meters. Now all I have to do is subtract the two. So because basically, if you think about this, if I have 87.37, I subtract, it's just like me getting rid of this, and now I will have only the communications tower. So 87.377, I already have that, and I'm going to take away 56, just copy it. 0.97149867, just like that. 30.4, right? So the communications tower, 30.4. So I'm going to say approximately 30.4. So this is approximately 30.4 meters. Double checking that. Yep. Okay, and then let's do the last one. So I think that one there was a typo on it. Not typo, but did it backwards. Typed it out backwards. Okay, last one. From the foot of the building, I have to look upwards at an angle of 22 degrees to sight the top of a tree. Here's the ground. Okay, let's try to make it more. Let's try to make it more level here. Okay. From the foot of a building, I have to look upwards. So here's a building. Okay, you're standing here. From the foot of a building, I have to look upwards at an angle of 22 degrees to sight the top of a tree. All right, let me get this up. Let me get this going. So tree. Okay, so from the foot of a building, I have to look upwards at an angle of 22 degrees to sight the top of a tree. So from here, there, upwards angle of 22 degrees. From the top of the building, 150 meters above the ground. So this building is 150 meters. So you, sorry, if you're on top of the building, from the top of the building, 150 meters above the ground, I have to look down at an angle of depression of 50 degrees. To So if I'm looking straight across, this will be 0 degrees. But to get that, if I have to look down at an angle of 50 degrees, angle of depression of 50 degrees, I have to look down at an angle of depression of 50 degrees to look at the top of the tree. How tall is the tree? Wow. This one is tough, right? How far from the building is the tree? Well, let's see. If I was to do if I just drew a line out from here, right? And we can figure a couple things out. Let's see. That's 22 degrees. And since these are parallel lines, and that means this is also 22 degrees. And that's 50 degrees. And that means that since the dotted line and this line is parallel lines, this is also 50 degrees. So in total, that big angle is 72 degrees. Okay. If that helps. Mm, we can actually use, let's see. Can we? Yeah, we can actually use what we did today actually to do this. This would actually be more helpful. Right, let's actually use what we do today, and then you can think of ways maybe we can um, use just plain right triangles, and I'll be thinking of it too. But all right, so let's just look at this blue one because I am going a little long, so I don't want to spend too much time thinking. We're talking about, let's look at this angle here, this triangle here. So that's 50 plus 22, so that would be, so this whole angle here would be 72 degrees. Okay, and we know the opposite side, or we know this side is 150 also. So we have 150. Okay, let's start at the top. We have 150 over the sine 72 degrees is equal to, right? And then let's what are we trying to find out, right? How tall is the tree? How far is the tree from the, right? Let's find out how long this piece is. Okay. And to get that, we need the angle here. Right? And if this is 50 already, right, and that's 9, so this would be a 90 degree right here. So that's already 50. Then how much do we have? Well, this should be 40. And let's go ahead and finish this up. If this is 22, right, and again, this is 90 right here. But that's 22 already, then that's 90 minus 22, right? Or 68. And this angle is 68. And I bet you if you add all these angles together, you get 180. Let's just try it out. So we got 68 plus 40 plus 72. There you go, 180. So inside that blue triangle is 180, just like how we knew. Um, so since we want to find this red, we'll go with, we'll call it x. So we'll go x over sine of 40. Okay, so all we did was we used 150 and sine of 72, and then we used the law of sine and equated that to x and sine of 40, just like that, like how we learned in class today. And this problem might have just been from one of the ones where you had to use the law of sine. All right, working that out, you would multiply both sides by sine of 40. So x would equal 150 times sine of 40 divided by sine of 72 degrees. So that gets you, let's see, 150 times sine of 40 divided by sine of 72. Okay, so that x right there, now we know is 101.38. And because I'm not done yet, I'm going to go ahead and use as many numbers as I can. 00335. Okay. And then now I'm going to go ahead, and now that I'm done with the blue triangle, I'm going to go ahead and utilize this red triangle over here. This one, this will tell me how tall the tree is. That's why I could just do SOHCAHTOA, because this will work, right? So I already know that this side is 101.380335, and I just want to find out this distance right here. We'll call that y. Right, so this is going to be opposite and hypotenuse, or we're going to work with the sine. So we'll go with sine of 22 degrees. We know that right there is equal to the opposite, which is y, over the hypotenuse, which is 101.38 and a bunch of them. So to solve for y, we're going to just multiply both sides by 101.38. So it'll be 101.38 times sine 22 degrees. And that'll tell you the height of the tree. And I already have that number, so I just got to go times it by sine of 22 degrees. And that means that the tree is 37.9776. Okay. And that's a final answer. And looking at all of these right here, they're all whole numbers. So I will say the height of the tree is approximately 38 meters. Okay, because the answer was 37.9. So I'm going to go ahead and use whole number 38. Another thing is, how far is the building from the tree? So I just got to figure out that with, let's call this W. Okay, how far is the building from the tree? And again, that's going to be adjacent and hypotenuse. So adjacent and hypotenuse, we're going to go ahead and use adjacent is W, right? So we're going to go ahead and use the cosine. So cosine 22 degrees equals adjacent W over hypotenuse, which is 101.38, blah, 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 right? And then, so if you multiply both sides by 101.38, you would get W equals 101.38 times cosine 22 degrees. Okay, so it's basically the same idea. Let me pull up the 101.38, which is the 150 sine. Okay, pull that up, that one. Okay, so that's times the cosine of 22. That's all you got to do. So W equals 93.99. So it's about approximately 94 meters. So we'll say approximately 94 meters. All right, that's all of them, I believe. There was that number that we couldn't get. Ooh, right, but I'll think about it. Not sure what you have to do there. Maybe you have to answer it in terms of just the side lengths and not really as a number. Okay. All right. This video's been long enough. I don't want to spend or have it at being like over an hour long. So, all right. See you tomorrow.